Hello. Today's lesson is on ratios and proportions, 7.2.2. The essential question today is what is a ratio and how can I use ratios to solve word problems? Yesterday we talked about proportions and how to solve them. This is going to be pretty related. All right, so a ratio compares two quantities. Normally we have a certain number of girls and boys in a classroom. I'm just going to make something up. Let's say there are 2 girls for every 3 boys in the classroom. That ratio can be expressed in 3 different ways. I can write it like this, 2 to 3. I can write it out in words, 2 to 3. Or most commonly, we write it as a fraction, a ratio of 2 girls to 3 boys. All right, let's do a quick couple examples. This one says to write the ratio of shaded squares to unshaded squares. Well, shaded squares, there are 1, 2, 3, 4 shaded squares. And unshaded squares, there's 1, 2, 3, 4, 5, 6, 7, 8 unshaded squares. So the ratio of shaded squares to unshaded squares would be a ratio of 4 to 8. I'm going to write that as a fraction. Now, one of the big things with writing a ratio is we normally don't write that as 4 to 8. If you can simplify a fraction, we should. Same thing for ratios. This 4 to 8, I can simplify into a simpler fraction. You might remember to do that, you just need to find something they're both divisible by. Here, 4 and 8 are both divisible by 4. So if I divide them each by 4, 4 divided by 4 is 1, 8 divided by 4 is 2. I come out with a ratio 1 over 2. So the ratio of 8 to 4 is correct, but I can write that more simply as 1 to 2. So I write it as a ratio of 1 to 2. This problem did ask me to write the ratio in 3 different ways, so that's one way. The other way I could have written it was a colon, ratio of 1 to 2. Or I could have written it out in words, a ratio of 1 to 2. That is a ratio of shaded squares to unshaded squares. All right, same problem, but this time I'm going to do the ratio of shaded squares to the total number of squares, which will be different. So shaded squares are still 1, 2, 3, 4 shaded squares. But the total number of squares is, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 total squares, so that ratio would be 4 to 12. Might be a good idea to pause this video, see if you can simplify that on your own. All right, 4 to 12, 4 and 12 are both divisible by 4. If I divide each of those by 4, I get a ratio of 1 to 3, which I can write as a fraction, or like that with a colon in between them. Or I can write it in words, a ratio of 1 with a literal word 2, 3, so 1 to 3. All right, why are ratios important? Well, before we talk about why ratios are important, just a definition that people get confused sometimes between, they're like, why we're talking about ratios and proportions, what's the difference? A ratio is when you just have a single comparison, like 5 to 7, or a single fraction. A proportion is when I have two ratios equal to each other. We can use proportions to help solve word problems. Ratios are part of that process. All right, so using ratios and proportions to solve word problems, here we go. In a photo, Dan is 2.5 inches tall and Emma is 1.5 inches tall. In real life, Dan is 70 inches tall. How tall is Emma in real life? So problems like these can seem difficult, but if we use this idea of ratios and proportions, it makes it a lot easier. The mistake I often see with this is people will just see numbers and be like, I see those numbers, 2.5 and 70, and I see a 1.5, so I'll put a 1.5 here. And I don't know something, so I put an X there, and they just throw numbers willy-nilly. Don't do that. Actually have some kind of thought of what ratio you want to come up with. If you want to start with just two numbers, that's fine. We can start with a 2.5 and the 1.5. Just make a note of what those 2.5s and 1.5s are. This is Dan's height. That is Emma's height. So when I set it equal to another ratio, I better darn well have Dan in the top and Emma in the bottom. The only other measurement I have is 70 inches. That's Dan's height. So I would put a 70 in the top. And Emma is what I don't know, so I put an X on the bottom. You could set up all sorts of different ratios that would all work. It doesn't have to look exactly like this. It just has to match, right? This happens to be a ratio of Dan to Emma. All right, once you set up that ratio, then it becomes pretty easy to solve. We talked about solving something like this yesterday. We can solve something like this using that idea of cross products. If I multiply these two together, I get 2.5x, and that'll be equal to those two together. 70 times 1.5. I'm going to just do that on my calculator. 70 times 1.5 is 105. To get x by itself, just divide. If I divide both sides by 2.5, I get x by itself, and x is going to be 42 inches. All right. This might be a good one for you to try. Pause the video, give it a shot. All right, I'm going to do it. I see only two numbers here. Oh no, I see three numbers. I see an 8 and a 248 and a 15. It really doesn't matter how I set up the ratio, so I'm going to start with the first two. I'm going to compare 8 to 248. But again, I'm going to make a note of what those 8 and 248 stand for. That's not just an 8, that's an 8 miles. And that 248 isn't just a 248, it's 248 calories. So when I set up an equal ratio, I better darn well have miles on the top and calories on the bottom. Let's see, it's asking me how many calories does biking 15 miles burn? 15 miles is a number of miles, so the 15 is going to go on top. I don't know the calories, x on bottom. Then you just solve it. Do that cross multiplying thing. 8 times x is 8x. 15 times 248, I use my calculator, I get 3720. And last, just divide by 8. 3720 divided by 8 is 465. Now that 465 isn't just a random number, it's something. It's, what did x measure again? Oh, it's right there. X measures calories. It's 465 calories. And that's all there is to it. All right, there's one type of word problem that can throw people off a little bit, so pay a special attention to this one. Mara's softball team played 154 regular season games. The ratio of the numbers of games they won to the games they lost was 5-2. How many games did they win? All right. Well, if I start with this ratio of 5-2, that's 5 games won for every 2 games lost. So if I want to set up an equal ratio, I need to compare games won to games lost. But they only gave me one number here. They said there's 150 regular season games. Now, I don't know how many they played. Well, I know how many they played total, but I don't know how many they won, so let's just say they won X. The question is, what do we put there? All right, well, let's think about this for a minute. If they won one game and they lost all the rest, how many did they lose? 153. How do you come up with 153? Well, if they only won one, you take that 154 minus 1, and you'll get your 153 games lost, right? We don't know how many they won. So if I wanted to find out how many they lost, it's just going to be the 153 minus however many they won. This will be the number of games lost. So if they won X games, they lost 154 minus X, because they played 154 games total. So the games lost is 154 minus X. Now you can do that cross product thing and solve this thing. If I multiply 2 times X, I'll get 2X. if I multiply 5 times 154 minus x, oh, I don't want to do that in my head. Let's just write that out. That's going to be, I'm going to write out 5 times 154 minus x. All right, if we see something like that, remember how to solve it? Distribute that 5 through. 5 times that and 5 times that. I'm not doing anything on the left side, so that's still 2x. 154 times 5 is 770 minus 5x. How to get rid of the 5x? You add it, because adding is the opposite of multiplying. I get 7x equals 770. Last thing, divide by 7. X is going to equal 110 games. All right, that's a more challenging type of problem. Definitely pay attention to it. I had one in here we could try on our own. Sure, let's do this one. And then there's just one problem like this on your homework. All right. Again, might be a good idea for you to try. Maybe look back at this and see if you can figure it out. I'm going to start it right now. I've got a ratio of girls to boys of 3 to 2. So I know there are 3 girls for every 2 boys in my classroom. I want to know how many of the students are girls. So if I want to know how many are girls, I'm going to have to set up another ratio. I don't know how many there are, so I'm going to say x girls. Question, if there are x girls, how many boys are there? Now, a lot of times people try to put a 35. They say, oh, I'll put a 35 there because I see the number 35. Again, don't do that. It's not 35 boys. There are 35 students total. So if x of them are girls, 35 minus x of them are boys. Then you can do this. Then you can do this cross products. Multiplying those two together, 2x. Multiplying those two together, 3 times 35 minus x. Do that distributing thing. 2x will equal 105 minus 3x. Add 3x to both sides. 5x equals 105. And finally, you divide by 5. X would be 21 girls. All right. Worksheet 7.1.2 is your assignment. I will be available during my office hour if you need any help with it. There's just a few problems. I think there's like 5 problems total. Good luck, and I will see you tomorrow.